Okay, let's look at the left and the right sums. All right. So let's say you have a graph of y equals x squared. So it's just a regular parabola. And we want to find the area under the graph going from x equals -1 to x equals 2. All right. So we want to approximate this area. All right. So here's the left sum using 3 rectangles. Right, so here is how it goes. Right, first thing we have to do is we have to find the width of each rectangle. We usually call it delta x. Right, so delta x can be found by simply finding the length of the interval. So since you're going from -1 to +2, you can simply do a 2 minus -1. Right, so which is 3, so that would be the length of the interval. Then since we were looking for L3, so 3 tells you the number of rectangles, so we divide by 3. Right, so this turns out to be, of course, 1. So each rectangle would have a width of 1, so you can see that here this is delta x is 1, and here's another delta x 1, and here is 1 here. All right, so here's how we draw a rectangle. So for the left sum, what you do is for each subinterval, so from -1 to 0, right, so we're gonna actually use the left endpoint and go up to the graph and use that value as the height of the rectangle. So use the left value to determine the height. So this is the approximating rectangle. Right, for this interval, left endpoint would be right here. So you have a rectangle with no height. Right, then for the third interval, using the left value, so here this is going to be the height. So you have approximating rectangle. Right, so left sum is simply this guy right here. So we're gonna add this rectangle, right, and you have a rectangle with no height, and you have a third rectangle which is right here. Right, so L3 is going to be, left sum is going to be, usually just add up all the heights together. So, right, so you can think of this, I'm going to call this guy f of x2, right? So what you do is, first you look at the f of -1, right? Then multiply by delta x, right? So that will give you the area here, right? The next one is f of 0, which happens to be 0 in this case, times the width. Right, I'm basically doing a base times height, base times height. Right, third one is f of 1 times delta x. So that will give you this area right here, right, which is going to be, right, so first one is if you plug in -1, -1 squared is going to be 1. So this is going to be 1 plus, right, f of 0 is 0 squared, so it's going to be 0, right, plus f of 1 is 1 squared, so it's 1, and multiply by another 1 because delta x is 1, so it's a 2 times 1, so left sum is actually 2. Right, right sum is very similar, but when you determine the height of the rectangle, we use the right endpoint. Right, so for example, for this guy, we're going to use the right endpoint, which is actually 0. So you have a rectangle with no height. So I'm going to use a red. So here, this is the first rectangle. All right, next one, and here we're going to use the right endpoint and go up to the function. And this is going to be the approximating rectangle. So here is the approximating rectangle. Right, third rectangle, go to the right endpoint and go up here. So you have a tall rectangle which looks like this. Right, so this is going to be the approximating rectangle, right? So R3 is going to be, right, so the first height is determined by plugging into zero, plugging 0. Next one, you plug in 1, so you have f of 1. And last one, you plug in x equals 2 to get the height, and then multiply by delta x is the same, right? So this is going to be equal to f of 0 turns out to be 0, plus f of 1 is 1 squared, so it's 1. And f of 2 is 2 squared is 4, and times 1, right? Which is going to be 5 times 1, so it's 5, right? So right sum turns out to be 5, right? So that's how you find the left sum and the right sum, right? And here's a remark. If you have an increasing graph, this one wasn't increasing, but if you, let's say if you have an increasing graph, then you can see that if you draw say left sum, so using that rectangle here, so here is the left sum, and you can see that the rectangle always misses some of the area, which means that if you're using a left sum, it's going to be always underestimate. So it's going to be a LN is always underestimate, smaller than the actual area if you have an increasing graph. And if you use the left sum, that's the other way around. So if you use a left sum, you can see that here the rectangle is always overestimating it, right? So right sum is going to overestimate the area when you have an increasing graph. All right, on the other hand, if you have a decreasing graph, then left sum is going to be here. Left sum is going to be the overestimate. You can see that you have some extra above the the graph, so you know that the left sum is going to be always the overestimate of the area. Then the right sum is going to be fall short. All right, so it's going to be underestimate, right? So if you have an increasing graph, left sum is going to be the underestimate, and the right sum is going to overestimate the area. If you have a decreasing graph, it's the other way around. All right, that's it. I hope that this was clear.